Hello, welcome to the video. In this lesson, we're going to be looking at section 10.1, where we're going to use sample spaces and probability. So this is our introduction into probability and statistics in the Algebra 2 textbook. Uh, Mainly what we're going to be looking at in this lesson is being able to use sample spaces to help us make conclusions for probability. So with that, uh, let's take a look at some examples. So here it says you flip a coin and roll a six-sided dice. They want to know how many possible outcomes are in the sample space, and they're asking us to list the possible outcomes. All right, so to think about it, looking at a coin, whether it's a quarter, a dime, or penny, whatever it is, there's two options. You flip it, and it either is going to be heads or it's going to be tails. All right, if we roll the dice, it's either going to land on 1, 2, 3, 4, 5, or 6. So, for instance, they're asking like to create a sample space here and list the possible outcomes. Like scenario 1 is you flip a coin, it's heads, you roll a dice, it's 1. So that's one possible outcome. Or you flip a coin, it's heads, you roll a dice, it's 2. That's the second possible outcome. So they want to know all the possible outcomes for this scenario. So there's several different ways that you can create a sample space. Here's one way. So I'll make like a little chart here and say like, all right, first one is like basically like task 1 or option 1 is you're going to flip a coin. So what are the different outcomes? You can either have a heads or you can have tails. Then from here, we're going to look at option 2 is we're going to roll the dice. So now we're going to look at all the possible outcomes once you roll heads. If you roll heads, you can either roll a dice as a 1, a 2, a 3, a 4, a 5, or a 6. Same thing goes for tails. You can go 1, a 2, a 3, a 4, a 5, or a 6. So basically what you're going to do is you're going to look at option 2 and you're going to count how many spots are there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what that means is there are 12 possible outcomes with respect to the sample space. In this example here, it says a student taking a quiz randomly guesses the answers to 4 true or false questions. What is the probability of the student guessing exactly 2 correct answers? So if they're completely guessing, that means because it's true and false, each question is either going to be true. So you have, question 1, question 2, question 3, question 4. It's either going to be true or it's going to be false. Same thing here. True or false, true or false, true or false. All right. And it doesn't matter what the question is because this particular student guessed. So they want to know what is the probability that this student got exactly 2 right. So not at least or not at most, they want to know exactly 2. So the first thing that we got to do is we got to figure out how many possible outcomes are here. Well, you could make the list of the sample space like we did before, but you could also think about it like this. So in the previous example, Option one, how many possible outcomes were there? There was two. In the second one, how many possible outcomes were there? Well, there were six. Well, if I took 2 and times it by 6, I'd get 12. So thinking about it in that aspect, let's say, all right, so how many possible outcomes are here? There's 2, there's 2, there's 2, and there's 2. If I were to multiply all of these together, I would get 16. So there's 16 possible ways that this particular individual could have gotten answers correct for 4 true or false questions. All right, he could have gotten them all right. That's one scenario. He could have gotten them all wrong. That is another outcome. But what we need to do is we need to figure out um, what this person got for exactly 2. So in order for us to figure that out, what we need to do is kind of like, all right, if you got 0 correct answers, you got 1 correct answer, you got 2 correct answers, 3 correct answers, and finally 4 correct answers. So there's only, like I said, there's only one scenario for 0 and 4. So you get them all incorrect. So that is one possible outcome. All right. Here's another one possible outcome where for 4 correct answers, you got all 4 of them correct. But now all we're really interested in is 2. So let's just take a look at where you get exactly 2. So let's say in a scenario you got the first 2 right, but the last 2 wrong. All right, that's one possible outcome of getting exactly 2 right. Another way is saying like, oh, I got the second one wrong, but the first one wrong, but the second and third one correct, and then the fourth one was I got wrong. All right, still exactly 2. Another way is I got 1 and 2 were wrong, incorrect, and um, 3 and 4 were correct. So now right now I have 3 possible outcomes with exactly 2 answers correct. What if I went correct for first? What about incorrect for 2 and 3, and then correct for 4? All right, and then what about if I went correct, incorrect, correct, incorrect, and then I think there's one more where it's incorrect, correct, incorrect, correct. So there are 1, 2, 3, 4, 5, 6 possible outcomes where you can get exactly 2 right. So probability here in this particular instance, we are going to take the number of successes here, which is 6, divided by the total number of outcomes, which is 16. So the probability of you getting exactly 2 right is 3/8, and that is like 37.5%. Here, this is one of the concepts where they talk about the complement of an event. So anytime you have this bar on the top here with respect, so like this P means probability. And this bar, so it's like a bar, this means they're saying they want the probability of something is not going to happen, or it's not possible. So in order to find the probability of, let's see, actually it's abbreviate it like this. The probability of something that's not happening, the equation you're going to use is 1 because there's a 100% chance of something happening, and then subtracted by the probability of that happening. Because anytime you are dealing with probability, you are dealing with numbers between 0 and 1. Numbers between 0 and 1. So if you kind of looked at it, and so like you got 0, you got 0.25, you got 0.5, you got 0.75, and then you got 1. All right, so if you're in this between 0 to 0.25, it's highly unlikely. Okay, so 50%, it's either way. All right, you get more in that 75% range, it's more likely. And then one having one which 100% means that it will happen, or this one means that it won't happen at 0%. Okay. So probability deals with values between 0 and 1. In in this question here, there it says when two six-sided dice are rolled, there are 36 possible outcomes, which makes sense. 6 times 6 is 36. And they show it to us. So they want us to find the probability of each. So here they want us to find the probability that the sum is not 6. So in order for us to figure this out, they're going to say, look, well, since they use the word not, what we're going to do is we're going to try to find the probability, take 1 minus the probability of a sum equaling 6. So, like for instance, like, oh, like 5 plus 1 is 6, this one right here. Oh, well, let's look for 2 and 4. Like those two are values that are going to make 6. So looks like these two are going to make 6. These two are going to make 6. These two are going to make 6. There's 1, 2, 3, 4, 5. There's 5 of them. So 1 is going to be subtracted by the probability of the sums being 6 are 5 out of 36 because there were 36 possible outcomes. So to figure out what it's not, I'm going to take 1 minus the probability of their sum being 6. So in this particular instance, we can say that there is 31 out of 36 chance of you rolling a dice um, that's not a sum of 6, which is about 86.1%. So it's very likely that that would happen. In this scenario, they want us to figure out a sum that is less than or equal to 9. So same thing here. So that means here we're going to go probability of it not being that. So what we're going to do is we're going to say this is going to be 1 minus the probability of it being greater than or equal to 9, because there's less values for that. Okay, so things that are greater than 9. So if I erase this, so like 6 and 6 is 12. This is 11. This is 10. And then that's 9. And then we would go, this is what, 11, 10, 9. Then we got 10, 9. And then this would be 9. So it looks like we got what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'm sorry. So it can't be equal to, because equal to is part of this one. So it just has to, my apologies. This one means it would just have to be greater than 9. My bad. So, my bad. So it would be this one, this one, this one, here, here, and here. Yes. 1, 2, 3, 4, 5, 6. Yeah, so there's only 6, because the greater than or equal to part of is part of the other probability. So 1 minus 6 over 36, that is going to be equal to 30 over 36, which gets reduced to 5 over 6, which is about 83.3%. So another one that's highly likely, that is, the sum would be less than or equal to 9. All right, so here it says you throw a, a dart at the board shown. So we got the diagram here. Your dart is equally likely to hit any point inside the square box. or square board, I'm sorry, you are you more likely to get 10 points, which is in the like the bullseye spot, or 0 points, which is on the outside? So the first thing we're going to do is I'm going to look at the probability of you getting 10 points. So in order to do that, we're going to look at area. So in this particular instance, the area of the 10-point circle has a radius. Since it has a radius of 3 inches, we are going to say that this area of that circle is, pi r squared. So it's going to be 9 pi, because 3 squared is 9. So it's 9 pi. Looking at on the bottom, is I want to figure out the area of this. So since this is 3, this is 6, this is 9, that means that this is 3, 6, and 9 also here. So this makes this 18. So since it's a square, 18 times 18 is 324. All right. So if you take your approximations that you can, or do some uh, uh, simplifying, this is going to be like pi over 36. And if you just use like 3.14 for pi to get a percentage, it is about 8.73%. Okay. So that is the probability of you getting 10 points. So now to figure out what you're going to get for 0 points, along the edge, I got to figure out the probability of getting 0 points. So essentially what I got to do is I got to take the area of this whole thing and I got to subtract it by the area of the larger circle. So the top is going to be the area of the entire thing, which is 324, and then it's going to be subtracted by the large circle. Well, the radius of that is 369, so 9 squared is 81, so it's going to be subtracted by 81 pi. It's going to be all divided by the entire box, or entire square, which is 324. Doing some reducing, 81 and 324 is divisible by 81 by 4. So that means if I could reduce this to 4 minus pi all divided by 4, using 3.14 as pi, you get about a percentage of 21.5%. Since 21.5% is larger than 8.73, it is more likely that you would receive 0 points. And that is being able to look at sample spaces and probability. Hope this helps. Till next time.